Now let's consider the refraction through a prism and prism formula. So what is that exactly? The prism. So it is nothing but a kind of weight shaped structure. It is having the rectangular and triangular faces. Mostly that is a three triangular faces and that is a three rectangular and two triangular faces. And what we used, that prism, the application for that prism, is just nothing but to separate that white light into its colors. So that you might have heard the another thing that we can do over here. So how the refraction through the prism occurs, and based on that we are going to derive the prism formula. So let's say this is the incident ray which I have shown in this diagram. Yeah, so according to that, so this is the incident ray, the normal at that interface AB, then again it will get bent towards the normal. So the refractive index, obviously it is greater as compared to air. The refractive index is, that might be u mu, then this is R1. Then again it will just move through that prism, it will strike on another interface, that is your AC. Then further the angle of incidence, that is the R2, and again it will just come out. Okay, so let's say this we will call it as the angle of emergence. This is angle del. So this is nothing but, if you just back produce this ray, so this is angle del. So that angle del we will call it as a angle of deviation. So this del is nothing but your angle of deviation for this particular case. Yeah, I is the angle of incidence, R1, R2, they are the angle of refraction. So fine. So what you have to do exactly over here, again the same thing we can do for this particular case. So this is R1. Now definitely this one is nothing but I minus R1, and definitely this one you can say that again E minus R2. Okay, so this del, so if you just consider this small triangle over here, so this is how we can just write it down. So this is I minus R1, then this is E minus R2, and this is your del. Yeah, so del is equals to I minus R1 plus E minus R2. So definitely again del is equals to I plus E minus R1 plus R2. This is one expression that you can write it down. Then you have to consider that quadrilateral, yeah, so in which the two angles are 90 degree. Yeah, so this is angle A and this is angle N. Okay, so you can say that angle A plus angle N, it has to be 180 degree, because already these two, let's say this two Q and that is R, they are 90 degree. So A and N, it has to be 180 degree. Fine. And again in this one, the below the one here, I can say that, so this is R1, then this is R2, and this is your N. Fine. So this is R1 plus R2 plus N is equals to 180 degree. So this is second equation, this is third equation. So if you just compare these two equations, then definitely again what you can say, that A is equals to R1 plus R2. So if I just consider this value, del is equals to I plus E minus, again that is your R1 plus R2, which is A. So I plus E is equals to A plus del. Yeah, so this is the important relation between angle of incidence, angle of emergence, your angle of prism, and that del, which is the angle of deviation. So now next, based on that, you have to just draw the graph of your angle of incidence and the value of your deviation. For the different value of your angle of incidence, you have to just check it out, the deviation. Then you will find that initially the angle of incidence goes on decreasing as I increase angle of incidence. Yeah, so the deviation goes on decreasing, then at a particular value of your angle of incidence, the deviation is minimum, and again it starts increasing. So this del is equals to del M. Yeah, so for this case we can say that I is equals to E. So for this particular case we can say that it is nothing but I is equals to E. So how we can just do that? So for minimum deviation, so the condition, so for minimum deviation, the refracted ray, so for minimum deviation, the refracted ray is exactly parallel to the base. Yeah, so when we can say that, so this refracted ray is exactly parallel to the base. So in that case, obviously your I and E both are same. Yeah, so definitely for this particular case, your I and E both are exactly same. So we have just write that. So the expression that we have written, I plus E is equals to A plus del. Yeah, so this is 2I is equals to A plus del. Then again I is equals to A plus del M upon 2. Fine. This is also how we can write it down for this particular case. Now the next thing that we can do for this particular case also, that is mu is equals to sine I upon sine R. Okay, so sine I obviously that is sine of A plus del M upon 2, again that is the sine R. Now since again inside that the R1 R2 will also be same, the R1 R2 they are also same. So what we can write it down, if R1 and R2 they are same, we have just got the result. Yeah, so R1 plus R2 is equals to A. So this one you can also write it down, 2R is equals to A. So this is nothing but A by 2. So this is your Prism formula. So mu is equals to sine of A plus del M upon 2, again upon sine of your A by 2. So this is what we've been called it as a Prism formula. Yeah, so that is the expression that we have derived for the Prism formula. At the same time, the most important thing over here, the condition for the minimum deviation. So when the refracted ray is exactly parallel to that base, so in that particular case the deviation is minimum, and your I and E both are same, as well as R1 R2 they are also equal, and this is what you will get the condition for the same. Now we have to find the deviation through a prism of a small angle. Just we have derived the Prism formula, that mu sine of A plus del M upon 2 and upon sine of A by 2. Okay, for the very small angle, obviously we know that sine theta is approximately theta. Then mu is equals to A plus del M upon 2 upon A by 2. So mu A by 2 is equals to A. Yeah, okay, further you can just write it down, A plus del M upon 2. So this one mu A is equals to A plus del M. So this mu A minus A is equals to del M. So A you can take common, mu minus 1, which is equals to del M. So this minimum deviation you can write it down, A into mu minus 1. Okay, so that is what you will get, the deviation through a prism of a small angle. Generally it is given below 10 degrees. So for that case you will consider that as nothing but deviation through a prism of your small angle. Yeah, and that is the expression that we have got, that del is equals to A into mu minus 1.